All right, let's dive right into this explainer. If you've ever built an API and found yourself wondering, okay, where exactly should my data validation stop? And where does my business logic actually begin? Well, you're in exactly the right place. Today, we're dissecting a totally critical backend architecture lesson for scalable apps. We're going to break down the exact boundary between wire schemas and domain invariants, and we'll be looking at this through the lens of modern FastAPI, Pydantic v2, and SQL Alchemy 2.0. To really get why this boundary is so absolutely vital, picture this. It's 3:14 a.m. You're the on-call engineer at a company called Lattice Telemetry. Suddenly, one of your biggest customers, Tritan Aluminum Plant 6, completely loses a manufacturing line. I mean, the physical machines have literally stopped spinning. But here's the truly terrifying part. Your back-end API ingested the data just fine, and the customer's dashboard, it's still showing a bright, happy green. Because of that false green light, 81 entire minutes passed silently before anyone realized the line was actually dead. Think about the massive cost of 81 minutes of halted manufacturing at an industrial scale. And you know the crazy thing? The reason this happened wasn't some spectacular server crash or a database timeout. No, it happened because a vital business rule was completely swallowed up by a simple wire schema. So the root cause of this massive failure was conflating our boundaries. The Pydantic class in the FastAPI backend basically just checked the data's shape. It looked at the JSON payload, which was an empty list with some optional fields, and it just said, yep, looks like perfectly valid JSON to me. But it completely missed the core business rule, the domain invariant. That rule states that if a heartbeat sensor stops reporting for 60 seconds, the availability is unknown. The wire schema successfully validated the network payload, sure, but it completely swallowed the missing heartbeat case. Section 1. The core concept, DTO versus entity boundary. To stop silent outages like this from ever happening again, we absolutely must strictly separate our responsibilities. There has to be a very clear dividing line. Pydantic version 2 is incredibly fast thanks to its Rust core, obviously, but its sole job is network validation. It should only be asking things like, does this JSON have the right field names, or are these timestamps ISO 8601? That's the wire shape, period. Your domain model, on the other hand, enforces the actual business requirements. That lives over in your service layer and asks the deep questions like, does this reading actually belong to the right tenant, or does it violate a cross-field mathematical rule? Conflating these two, well, that's exactly how a simple API rename can accidentally delete a critical business rule. Section 2. The domain invariant. Understanding OEE. Let's ground this boundary concept by looking at the specific math involved in that manufacturing example we talked about. OEE, or overall equipment effectiveness, is the absolute gold standard for tracking manufacturing efficiency. It was defined way back in 1988 by Saiichi Nakajima, and it's still the canonical KPI today. To put that into perspective, a typical mid-market manufacturing plant usually sits at around a 60% OEE, while a world-class, hyper-optimized plant hits about 85%. And this metric exposes our exact invariant problem. You see, OEE isn't just some single number you can validate with a quick, is it greater than zero check. No, it's a strict multiplicative decomposition, availability times performance times quality. Because this metric requires a cross-field calculation to ensure all three of those numbers multiply together correctly within a floating point margin. This math absolutely belongs in the domain model. A request schema simply isn't built to enforce that kind of logic. Section 3. The rebuild. Routes, services, and repositories. So how do we actually rebuild the FastAPI backend to correctly enforce these boundaries? Well, at the route layer, the very edge of our API, we're going to use Pydantic strictly for the wire contract. We use the setting model config equals forbid, which firmly rejects any unknown field sent by, say, partner integrations. We also explicitly declare our response model to handle partial successes. For example, if a bulk ingest of 100 readings has 5 bad rows, the route cleanly returns the accepted IDs and the rejected IDs. The route handles the HTTP semantics and literally nothing else. Now, moving inward to the service layer, the rules change entirely. This must be a pure Python module. It accepts strictly types domain inputs, and it wholly owns that OEE math we just talked about. And here is the golden rule for this layer. Absolutely zero fast API imports. I mean it. No request, no response, no depends. Why? Because this exact same service function might need to be called by a background cron job or maybe a Kafka consumer tomorrow. If it relies on an HTTP request object, you've completely ruined its reusability. Finally, down in the repository layer where we actually interact with our database like Postgres or TimescaleDB, we're using SQL Alchemy 2.0 async. The absolutely strict rule here is that your functions must return typed domain objects. Never, and I mean never, return raw Python dictionaries. Returning raw dictionaries destroys all your downstream type checking and just bleeds persistence details all over your pristine business logic. Section 4. Guided Practice. The Get Endpoint. Let's look at a practical example. Here's a question for you to ponder as we design this Get Endpoint together. If the service layer strictly has no fastapi imports, and therefore really shouldn't be returning the fastapi Pydantic response model, what exactly is the object it computes and passes back up to the route? The answer is a domain concept called a value object. In our specific case, it returns an OEE snapshot. We implement this as a frozen Python data class. It has no database identity. We honestly don't care which specific snapshot it is in a database table, but it contains that crucial multiplicative invariant we discussed. It guarantees that the math is perfectly correct. The route then takes this pristine, mathematically sound OEE snapshot and simply translates it into the JSON wire schema for the client. It's clean, it's separate, and most importantly, it's safe. Section 5. Common traps to avoid. Okay, even with these beautiful architectural rules in place, developers still tend to fall into a few common traps. Let's look at the first two major pitfalls. First step, never put fastapi.Depends in your service layer to just magically pull in a database session. It literally makes testing a nightmare. Instead, pass the session as an explicit argument. Remember, composition over magic. Second, as we touched on earlier, never return raw dictionaries from your repositories. If you do, every downstream caller has to guess the dictionary keys. And if a database column gets renamed, boom, your codebase breaks silently. Always return a typed domain object. Furthermore, you've got to keep complex business logic out of Pydantic's field validators. Checking if a tenant has paid for a premium SLA tier, that absolutely does not belong in your JSON parsing logic. Move that directly to the domain. And finally, trap number 4, always remember to use exclude_none equals true in your response models when you're dealing with partial data. Think about it. If you return a literal null for an incomplete time window, front-end client dashboards might interpret that null as a mathematical 0. Suddenly, your dashboard is showing a flatline 0% outage that didn't actually happen at all. Section 6, Final Reflection. Let's cement this core architectural rule. I want to leave you with this final provocative thought to really anchor your memory for your next backend build. What is the right boundary between your request schema and your domain model? Remember, request schemas validate what crosses the network. They should only change when your API contract changes. Domain models, however, validate what your business requires. They change only when the business rules change. Keeping these two things strictly separated is the hallmark of a resilient, professional, and easily tested codebase. Thanks so much for joining me for this explainer, and happy building!